Let's start with steel. Steel is an alloy of iron and carbon, which is with a carbon content of being less than 2%. In addition, various alloying elements like sulfur, phosphorus, manganese, nickel, chromium, copper, etc. Some are added in a small proportions, so they vary according to the properties required in steel. So whichever is required more, we add more. Like chromium is added to give more corrosion resistance, like that. So different materials are added to get different uh, grades, or sorry, different properties of steel. So classification of steels, mainly they are classified into carbon steels, alloy steels, stainless steels and tool steels. So under the stainless steel you have mild steel or a low carbon steel, medium carbon steel, high carbon steel, ultra high carbon steel. Whereas in the alloy steels you have high strength low alloy steels, medium alloy nickel chromium steels, maraging steels, manganese steels. In the stainless steels you have austenitic steels, ferrite steels, martensitic steels, duplex steels, and PH steels, that is precipitation hardened steels. Whereas in the last one, the tool steels, you have cold work tool steels, shock resistant tool steels, high speed tool steels, special purpose tool steels. So we'll see one by one, not all, some are in detail. So now before going into the different classification, you'll see the effect of alloying elements on the properties of steel. There are many elements which vary the properties of steel when you add in different proportions. So first one we'll see, that is carbon. What happens when you add carbon? So carbon is a most important alloying element ingredient in steel because it has a direct effect on the physical properties of the steel. So there will be a direct change. Also, it is the amount of carbon content which forms the factor for difference between steel and the cast iron. So we know steel and cast iron are two different elements which is varied by the addition of carbon. Steel with a low carbon content has the same properties as iron material. Okay, whenever you have low carbon, it is same as iron, which is soft but easily formed. Formed means that the shapes can be changed. So as the carbon content increases, the metal becomes harder, acquires greater tensile strength, and becomes increasingly responsive to heat treatment. With the further development in strength and hardness. Okay, so if hardness can be further still increased. So however, like the increase in the carbon content will have the other effect like lowering the ductility of steel, making it more brittle. Okay, so the maximum amount of carbon content in steel that you can add is 2%, and above, if you add 2%, it will become cast iron. So that is the effect when you add carbon. Next one, if you add manganese, what happens? So that is the next important element after carbon. So its function is both, like it is a deoxidizer and also impart strength and responsiveness to heat treatment. So manganese is usually present in quantities from like 0.5 to 2%, but certainly some steels are made in the range of 10 to 15% depending on the special cases. Next one, that is chromium. Chromium increases response to heat treatment, like it imparts a good wear resistance at high hardness. Like, however, chromium decreases machinability and hardening temperature, ranging from unless balanced with nickel. If it has to be balanced with nickel, so most chromium-based alloys contain 0.5% to 1.5% chromium. When chromium addition exceeds 5%, the high temperature properties and corrosion resistance of steels are greatly improved. Next one, that is sulfur. Still there are many other. So sulfur, which increases the machinability in steels. However, its addition is restricted to 0.05%, because if it is more, the excess results in the cracks during hot rolling and forging operation. Next one is phosphorus. Phosphorus is also added, which is also present in steels. In addition to increasing yield strength and reducing the ductility at lower temperature, phosphorus is believed to increase the resistance at atmospheric corrosion. However, the addition of phosphorus in large quantities, if you add more, which increases the brittleness and cold shortness of steel. So its addition is kept below 0.05% in most of the steels. Next one is a nickel. Addition of nickel to steel. What happens? So it will increase the strength and toughness of the steels. Okay, however, it has the least effect on the hardness of the steels. In addition, the ranges its amount the composition ranges from 1 to 4%. Although for some certain application, percentage as high as 36% is also used in some cases. Steels containing nickel usually have more impact resistance, especially at low temperatures. Certain stainless steels employ nickel up to about 20%. Only the stainless steel. Next element which can be added to steel for changing its property is the copper. Copper is one more element which can be added. Normally, it is added in the amounts of 0.15 to 0.25%, like to improve the resistance to atmospheric corrosion and to increase the tensile and yield strength with only a slight loss in ductility. Higher strength properties can be obtained by precipitation hardening process. So if you want high hardness, you have to go for precipitation hardening process. Next type of steel, that is alloy steels. Second type, the term alloy steels, alloy you heard many times. The term alloy steel used in many places. It's like it's due to the nickel, the alloying element like nickel, chromium, molybdenum, manganese, silicon, vanadium, etc. So these are included. Alloy steels are generally more responsive to heat and mechanical treatments than carbon steels. Some of the commonly used alloy steels, like already it's mentioned earlier, it's a high strength low alloy steels, medium alloy nickel chromium steels, maraging steels, manganese steels. We will see one by one. The first one is a high strength low alloy steels. High strength low alloy steels have been developed for use as a structural steels, so that the welding can be carried out for joining sections where riveting is not required actually. So the term low alloy is used because the total amount of alloying element is less than the 2%. So one form of such steel has 0.2% of carbon, uh, and also 1.5% manganese, 0.003 to 0.11% niobium, and 0.003 to 0.1% vanadium. So all these percentage has to be um, kept in mind. Okay, the high strength is achieved by adding carbon. So if you want more strength, carbon is added instead by addition of manganese, niobium, and vanadium in suitable properties. Sorry, in suitable proportions. Okay, so these are added to get other properties. Next one is the medium alloy nickel chromium steels. So the term medium alloy steel is used when the total amount of alloying element is between 2 to 10%. So medium alloys, these type of steels are widely used for moderate to high tensile strength. and harden and when hardness is required. So when chromium and nickel is added to steel, they will limit the grain size property of nickel, with the carbide forming a property of chromium combined to give a very widely used alloy steels. The nickel chromium steel contain about zero point 0.1 to 0.55% of carbon, 1 to 4.75% of nickel, 0.45 to 1.75% of chromium, and zero point 0.3 to 0.8% of manganese. Like they are mainly used in those applications where heat resistance or corrosion resistance is required, where the like in furnace and all heat treatment heat resistance is required more. Next one, the managing steels. Like managing means the transformation. Managing steels are high strength steels and high alloy steels, which is done with the help of precipitation hardening. As I told, it is the meaning is the transformation which occurs after the steel is cooled from austenitic state to the production of martensite, followed by aging. That is a precipitation hardening. That is why the name given as martensite. So this type of steels usually contain 18% of nickel, 7 to 8% of cobalt, 5% molybdenum, and about 0.5% of titanium. The carbon content is kept very low, like below 0.3% here, since otherwise the high nickel content could lead to the formation of graphite in the presence of carbon in structure, and this will become the consequential this will result in a decrease in strength and hardness. These type of steels are used in those applications where high strength with the good fracture toughness is required, like aircraft under carriage parts, punches, dies for cold forging, die casting, and extrusion dies for aluminium. So these are related to alloy steels. Next one is the stainless steels. Stainless steels is defined as a iron carbon alloy with chromium content ranging from 11.5% to 25%. Depending on the properties desired, this will vary. Chromium helps to resist corrosion in steels, as I already mentioned. Stainless steels get its name because of it doesn't corrode or stain easily compared to other steels. That's why the name given as stainless steels. This resistance to attack is due to the naturally occurring chromium, which forms a rich oxide film on the surface of the steel. The film is rapidly self-repairing in the presence of oxygen and damaged by abrasion. Abrasion, the cutting, machining, all these processes. So stainless steels, they are mainly divided into five basic categories like austenitic stainless steel, ferrite stainless steel, martensitic stainless steel, duplex stainless steel, precipitation hardened stainless steel. We'll see one by one. The first one in that is austenitic stainless steel. So all these categories are named related to the microstructure formed. Okay, so like austenite, ferrite, all these are named based on the microstructure form. Austenitic and ferrite grades account to approximately 95% of stainless steel applications. First two types, the austenite and the ferrite. First one, you'll see the austenitic stainless steel. So when nickel is added to stainless steel in sufficient amounts, the crystal structure changes to austenite. Austenitic steels, which are generally non-magnetic, non-heat treatable steels, but usually used in annealed and cold work to improve certain properties. Austenitic grades are the most commonly used stainless steels, accounting for more than 70% of total stainless steel production. Mostly they are used in 70% in steel production. Like typical composition will be 8 to composition, like 8 to 18 grade of stainless steel consists of 18% of chromium and 8% of nickel, along with other elements like carbon, manganese, etc. Since this type of steels is soft and prone to surface damages, it is very soft and widely, that's why it is used in a low strength application like kitchen utensils where knives, forks, spoons, etc. All these are used. Usually the austenitic steels are also used for computer floppy shutters, disk shutters, computer keyboards, springs, kitchen sinks, food processing equipment, artificial architectural application, chemical plant and equipments like that. Okay, so these are some other uses of austenitic steel. Next one is the ferrite stainless steels. The ferrite stainless steel is usually a magnetic in nature, highly corrosion resistance, but it's very less durable compared to that of austenites. It cannot be hardenable by heat treatment. You can't make it very hard. Uh, you can you have different rates of ferrite steel depending on the chromium content, like 12 to 22% of chromium with a little bit of nickel and carbon content. Molybdenum, aluminum, or titanium are mostly added to get different properties, the favorable properties if you require. Ferrite stainless steels are used in, like again, it is used in computer floppy disk hubs, automotive exhausts, water tanks, other like hot water tanks, etc. Third one, martensitic stainless steels. Martensitic stainless steels are not as corrosion resistant as we discussed in the previous two types, but are extremely strong and tough, as well as highly machinable and can be hardened by heat treatment process. This type of steel contains usually 12 to 14% of chromium, zero point 0.2 to 1% of molybdenum, 0 to 2% nickel, and about zero point 0.1 to 1% of carbon. Martensitic stainless steels are usually slightly more brittle compared to that of other types of steel. That's why they are mainly used in the preparation of knife blades, surgical instruments, shafts, spindles, etc. Last one, that is a duplex stainless steel. Duplex stainless steel have a mixed microstructure. It is not a single microstructure. It is a mixed microstructure of austenitic and ferrite. Like the aim, usually they prepare with the 50-50 range. Mix will be 50-50%. Commercially, which is available, they will vary to 40-60 also. Um, Duplex steels have improved strength and corrosion resistance compared to austenitic steels, stainless steels. They contain 19 to 28% of chromium and up to 5% of molybdenum with low content of nickel compared to that of austenitic stainless steel. The low carbon content makes the steel insufficient to generate fully austenitic structure because of chromium, no sorry, because of nickel. And that's why you will get the combination of ferritic and austenitic structure. This type of steel is used in marine applications usually, and a desalination plant, heat exchangers, a petrochemical plant, etc. This is about stainless. Next one, it is the tool steels, like carbon steels and alloy steels, which you have already seen, which lack certain characteristics like toughness, hardness, and strength, like in elevated temperature. So this, which is the main requirement, the primary requirement in the high speed cutting tool application. In that case, tool steels are required, which is generally a ingot cast wrought products that are capable of withstanding high loads and remain stable at elevated temperatures. They are a special class of steels which are primarily used to make tools in the manufacturing process, as well as in the machining metals, woods, plastic, and all these application. And different types of steel classified under tool steels are like cold work tool steel, shock resisting tool steel, mold tool steel, high speed tool steel like it's called HSS, special purpose tool steel. Like all the above in this five types, the high speed steel is widely used in manufacturing application. So we'll discuss on that. So high speed steels, HSS, which is called because they are capable of cutting at high speeds, very high speeds, about 4 times faster than the carbon steel tools. Also, which has which was the only cutting tool available for a metal cutting operation earlier. The details of the combination, like it is a combination of tungsten, molybdenum, chromium, vanadium. Different proportions, they vary. The cobalt is sometimes added to improve the hardness or the hot hardness in the of the HSS. There are two basic types of high speed steels. If you see, one is the T type, then we see a M type. T type HSS in which tungsten is a principal alloying element with composition ranging from 12 to 18%, whereas in M type HSS the molybdenum is a principal element or the principal alloying element with a composition ranging from 4 to 9%. In a T-type category, 1841 HSS is a common use. This is a grade, the code or specification, which contain 18% of tungsten, 4% chromium, 1% vanadium, in addition to carbon of 0.7%. Whereas the M-type, 6642 is the usual grade, the category, where 6% molybdenum, 6% tungsten, 4% chromium, and 2% vanadium, with the addition of a carbon content again 0.6% is usually used. So these are types of different steels. So next we'll see the steel designation. As I told, there are different proportions, different standard grades of steel. So some name should be given. So for that reason, the Society of Automotive Engineer, which is called SAE, and American Iron and Steel Institute AISI, has established standards for specific analysis of steels. The system generally uses a 4-digit number, these standards, which represent the standards for steel specification. So in that 4-digit, first digit indicates whether it is a carbon steel or alloy steels. So based on that number, we decide. The second digit indicates the modification in the alloys. So once we understand what type of steel, we can see what modification it can be done, how it is done. And the last two digits denote the nominal carbon content in percentage, like hundredths of the percentage. Whatever number is given, divide by 100, that will be in percentage. Last two numbers. Some of the few common types of steel designation is given in this table. This table indicates designation and types. So if you have these designation, it indicates that these types. Examples are given here. The illustrate designation. First one, SA 1040 will be the number given. So it is understood. It is SA grade with one digit indicates the carbon steel. You can see in this table here. And 0 indicates there is no modification in the steels. It is a plain carbon steel. And last two numbers, it is the carbon content. So 40 is the number given. So divide by 100 and it's in percentage. Next, second example, SAE 2515, 2515. 2 indicates, like see in this table, 2 indicates nickel alloyed steels. and the second number is 5. 5 means that it is a nickel alloy, so nickel percentage is 5%. Major alloying element is nickel, so its percentage is 5. And last two numbers and 1 5, that is 15. 15 divided by 100 is 0.15%, which is the carbon content. So this is how you read the grade of steel, or it's the specification. So this is about the steels. So next we'll move to the remaining part in this module, that is solidification.